Most people think a boomerang comes back because of its curved shape. They're missing the real reason entirely. The curved shape is actually a red herring. A curved stick thrown into the air will just fall down, curved or not. So if the shape isn't the answer, what is? The answer lies in something invisible, something that happens the moment the boomerang leaves your hand. When you throw a boomerang, you're not just launching it forward, you're spinning it. That spin is everything. And here's where it gets strange. The boomerang doesn't spin like a frisbee. It spins like a gyroscope, tilted at an angle as it flies through the air. That tilt is the key. Here's the surprising part. When a spinning object moves through the air pushes on it differently depending on which edge is moving faster. One wing of the boomerang is moving forward through the air and spinning. The other wing is spinning the same direction but moving backward through the air. They experience different air pressure. This difference in pressure creates lift but not upward. It creates sideways lift. The boomerang wants to turn, and because the whole object is spinning, that turning force gets redirected in a way that makes the entire flight path curve. Not just arc downward, curve sideways, curve back toward you. This phenomenon has a name: gyroscopic precession. It's not unique to boomerangs. Spinning tops do it, bicycle wheels do it, satellites do it. Any spinning object that experiences a force will precess. It'll rotate its spin axis in a way that seems counterintuitive at first. But once you see it, you can't unsee it. But here's the catch: not every spinning object comes back. A boomerang is specifically shaped so that its wings have different angles of attack. This geometry amplifies the precession effect. The wings are twisted. They're tapered. Every curve serves a purpose. Indigenous Australians refined these designs over thousands of years through pure experimentation. What they didn't know, what they couldn't have known, was the aerodynamics. They just knew, if we angle it this way, spin it this way, throw it at this angle, it comes back. They were reverse engineering physics without equations, without wind tunnels, without any formal language for what was happening. The throw angle matters enormously. A boomerang needs to be thrown slightly upward at around 45 degrees to the ground with a specific spin rate. Too flat and it just dives. Too steep and it climbs too high and falls straight down. The sweet spot creates a circular or elliptical flight path. That's where the return happens. There's also air resistance to consider. As the boomerang flies, friction with the air gradually slows its spin. As the spin decreases, the precession weakens. The curve flattens. Eventually, the boomerang loses enough energy that it can't sustain its curved path anymore. It falls. Ideally, it falls near your feet. This is why modern boomerangs come in different weights and materials. Lighter boomerangs stay aloft longer but require more precise throws. Heavier ones are more forgiving but don't travel as far. The material affects how much spin you can impart and how quickly air resistance dampens it. Every variable is connected. So why doesn't a frisbee come back? A frisbee spins too, but it's designed to maximize distance, not return. Its spin axis is nearly horizontal. Its shape creates lift that keeps it gliding forward. The geometry works against precession, not with it. A frisbee's goal is to go far. A boomerang's goal is to come home. Modern sports boomerangs take this even further. Competition boomerangs are engineered to return to within a few feet of the thrower every single time. They've been tested in wind tunnels, refined with computer modeling. But the fundamental principle, gyroscopic precession amplified by specific geometry, that's ancient. That's Aboriginal. There's something almost magical about watching a boomerang return. It defies intuition. An object thrown away comes back, but there's no magic here, just physics. Just the marriage of spin and shape and air. Just what happens when an ancient tool meets the invisible forces that govern motion. The boomerang teaches us something quiet. It shows us that understanding the world doesn't require modern tools. It requires observation, patience, a willingness to iterate without knowing why something works. Indigenous peoples figured out gyroscopic precession through trial and error centuries before Newton. They were physicists without knowing the word. So the next time you see a boomerang arc through the sky and curve back, you'll know what's really happening. It's not the shape. It's not magic. It's a spinning object precessing through the air, following laws of physics that apply everywhere in the universe. It's an ancient tool that embodies a profound truth. Nature rewards those who listen. And that's why a boomerang comes back, not because it's curved, but because it spins in a way that makes the air itself turn it around. It's a conversation between physics and geometry, between ancient wisdom and invisible forces. And every time one returns to your hand, you're holding proof that understanding the world doesn't require a degree, it requires curiosity. Subscribe to discover the hidden physics hiding inside the everyday objects you've overlooked your whole life.